So hello and welcome back friends. Today the question number is 251, that is the kth largest element in the array, and this is one of the simplest question. Okay, so without wasting time, let's start with the video. In this question what we have to do, that we have to find the kth largest element of the array. So what we can do, if we think simply, if we have been given an array, here for example we have been given nums, and we have to find the second largest element of the nums. So what we can do, just we have to sort the element, and then we have to find the second largest element. How we can do it, let's see it. It's very simple. So a minute. So for example, here is one example. This is the nums, that is our array, and we have to find the second largest element from this array. So what we can do here, we have to first of all sort this array. So when we will sort this, we will get 1 2 3 4 5 and 6. If we write the index of it, then it will be 0 1 2 3 4 and 5. Now we have to find the second largest element. So this is our first largest element, and this is our second largest element. Okay, so what we can do, if we get the length of nums and then subtract k, then we will get the exact index 4 for the answer. So here the length is 6 and we have to subtract 2, so we got here 4. So if we do this, just only simply sort the element and then return this index, then our question will be solved. So it is a very simple example. So first of all, let's try this. So here we will sort the nums array. This is the simple brute force approach, and then we will return. What we have to return? We have to return nums, length of nums minus k. So I think that this should work, because it is very simple, no any magic here. So we can see that this is working absolutely fine. So if I will submit this, it will accept it easily. So it has just accepted it. But rather than solving the problem like this, now we are going to see some different methods and some different approach to solve the problem. So the approach which we will be using here, we will be using heaps. So using heaps we will be solving this problem. So let's try to solve this problem using heap. So if we want to solve the problem using heap, so heap is basically, we know that heap is a data structure from which we can efficiently take maximum or minimum element out. So there are two types of heap. Either we can use max heap, or we can also use min heap. But here we will be using min heap because Python inbuilt module, that is heap queue. Heap queue is a Python inbuilt module. Using this module, we will be using its two function, that is heap push along with heap pop. So heap push module takes two parameters. One is the list through which heap has been implemented and the value to be pushed, and heap pop just take the list and it pops out the either if we are using the minimum heap, then it will pop out the minimum value from the heap. So here what we have to do, that we have to take the kth largest element. So what we are going to do, that we will be making heap of length k. We will be making heap of length k, and since it is the min heap, so when we will give all the elements to the heap which size is k, then what it will do, it will eventually take all the elements greater than k into it, and the kth element at the minimum position. So we will be doing only this. For example, if we suppose here I will solve it so that we can make it more clear. So this is our example here. Okay, so let's dry run this problem so that we can understand it more clearly. So when since the k is 2, so size of our heap will be 2, and it is min heap. So if it is min heap, then 3 will be inserted directly to the heap, and then 2 will also be inserted to the heap. And if we are going to pop the element, then 2 will be popped easily, and it is min heap. So if we get any element greater than this element, that is this is the last element, minimum value, then we have to just insert that element into this heap, and heap size of heap is just constant, that is 3 and 2. Then we will be having our element 1, so 1 will come, but 1 is less than 2, so we will ignore it. After that we will get 5. Now 5 is greater than 2, so we will insert 5. When we will be inserting 5, we will be take out the 2, and heap will rearrange itself to form 5 3. So now our element is 3. Then again what we will be doing, we will be inserted 6. So 6 is again greater than 3, so we will be inserting 6, but 3 will be going out from the heap because length is always 2. Since it is min heap, so it will rearrange itself and it will be like 6 and 5. Then again we will be pushing here 4. So when we will try to push 4, but 4 we cannot push because 4 is less than 5. So in this way, at the end what we got, this is our answer, 5. If you have problem, then we will be again try running one next example. Okay, so this is our second example. Here we have been also given our nums, and now we have to make the heap of size 4. So we will be having 4 here. Okay, so simply understand that we have 4 elements here. Heap is implemented in form of tree, but we don't need to consider a structure of tree here. Just we have to consider that we have 4 elements, so our heap is going to store the 4 element. So 3 will be easily pushed, then 2 will also be pushed, then again 3 will be pushed, and again 1 will be pushed. And what will be the minimum of this? Simply if we check it, minimum will be 3 3 2 and 1. So this is the case our. After 1 we will be having our element 2. Now since 2 is greater than 1, that is the element here, so what we will be doing, we will be popping out this 1 and we will be pushing the 2 inside it. So it will be like 2 2 and 2. Again it will rearrange, but after rearranging it is the same because 2 is only here, so there will be no change. Now after 2 we will be inserting 4. So since 4 is also greater than 2, where is 2 coming from? This is the 2 only. So 4 is greater than 2, so we will be again put here 4, and we will put pop out the 2 from here. So what our heap will be like? Heap will be having this much of element. But what is minimum? Since 2 is minimum and we are implementing min heap only, so it will look like this. After 4 we will be having 5, and there are 2 5, so we will be having 5 1 by 1. So 5 is also greater than 2, so we will be again 3 also, and we will be pop out 2, and we will be having 5 here. And after that what will happen here? After that we will rearrange in the element so that minimum element can come forward. So it will be like 5 4 3 and 3, like this. After that we will be having again 1 5, so again we will put 1 5, and if we will put 1 5, then this 3 will be gone. So I can directly write here 5 4 and again 1 5 and 1 3 gone. If we again put one element here, that is the last element 6, so we will be putting here 6. If we try to put 6, then 3 will be go out, so this will be 4 only. So in this way we can say that here that is our fourth largest element is 4. This is first largest element 6, second largest element 5, third largest element 5, and fourth largest element is again 4. So in this way we can return our answer, and we can implement the question using the heap. So heap data structure is one of the most useful data structure when we have to need to find any kth largest element or kth smallest element. So based on the heap we can implement this very easily and efficiently. So we are going to use this and solve our problem using the heap data structure. So as I earlier said, for implementing the heap we first of all need one list. So I'll be declaring one list variable, and then what we will be doing here, I'll check while length of list greater than k. Otherwise let's have some other approach. So let's do like this. Rather than this, we will delete this and we will write for value in nums. So we will be getting one value one by one, and now I will check if len of lst less than k, then what we will do, we will push element into the list. But for that we will be using heap queue dot push and input, we will push list and value. Okay, so this is the way how we are pushing the element into the heap. After that, what we will be doing here, else list had length of list has been equal to k or it is greater than k. So what we will be doing here, first of all we will pop one element from the list, and then we will be pushed here. So we are going to do like this. First of all we will pop one element. So for rather than popping, first of all let's push, then we will pop the desired element. So for pushing, what we have to do here, again heap queue dot push lst and the value only, and then we have to pop also heap queue dot push lst, and at the end what we have to do, we have to just return heap queue, since it is min heap. So at index 0 we have the minimum value of the heap, not here heap queue, it will be list. So I'll just check it. So the method names are wrong here. We will have to write heap, here also heap push and heap pop, not push. This is wrong. There are too many heap pop. So now let's run the program. So now we can see that it has executed successfully. So let's submit it and check it. So it has been accepted successfully. So this is the way we are approaching the problem. So this is the simple problem, but we have to consider it how we are using heap. Just heap contains the any element, and we can efficiently pop out any largest and smallest element from the heap correspondingly, if it is a max heap or min heap. So that's all.